of the time actually goes into the cleansing and prepping of the data. So let's run this cell as well. And you see here that here we're doing additional featureizations. And based on the pickup hour, we could actually derive new features, such as when did this happen? Was it during night? Was it during the AM rush, the afternoon, the PM rush? And these are all additional data points that we can give to the model so that it can learn better and perform better. So that's why these are so important. Now we're getting closer to the modeling step, but before we can kind of start actually calling the algorithm that we're going to use, and this, to be able to train a model that's going to be able to predict if a customer is going to tip or not, which is a binary classification problem. We're classifying a yes or no in this case. We need to do something that's fairly common, which is called encoding. So in any type of data science problem, when you're modeling, you're going to run into encoding. For this one, we are going to leverage something that's called one-hot encoding. And as I mentioned, it's a fairly common method. We convert the string values. So if you take a look at the data set that we had here, you see that, hey, we actually have the weekday string, but it's actually a string. And models are picky because they like numerical values. So what one-hot encoding allows us to do is to pretty much convert our strings to numeric values so we can correlate them back. And of course, I could use a mapping function to do this, and that would be simple, you might think. But the truth is that it's a little bit more complicated than that. If I map, let's say, the strings to numerals just kind of as a mapping function or a mapping table, I might actually skew my model. And I don't want to do that. So this encoder removes that bias for me as well. So that's why it's so important. I don't want you to kind of go into the details of this, but one thing you can remember is that we're doing encoding. In this case, we're using one-hot encoder. So we're using an indexer and then encoding on top of it. You see that first we have an indexer, then encoder. And in order to look at the kind of encoded data, again, you're probably super tired of this. You're like, why is she continuously showing us this display function? But I really just want us to take a look at the data because I think it's important that that we look at so we do display encoded final, which is this data frame that you see here. Encoded finals in the name, and then limit 10. So if I run this one now, and I hope that you're following along with me on this one. Oh my gosh, something went wrong here. It's probably that I missed the name of the data frame, right? All right, let's try this again. Corrected the name of the data frame, so hopefully now this time it will actually execute. And yes, there we go. There we have the results, and let me scroll to kind of take a look at this. All right, so as I mentioned, we were converting the string values to these numerical values. So what one-hot encoding does is that it actually it shows us a vector, a numeric vector of a representation of the string that we just had. And models, they just love this. So the only thing you need to think about is that this encoding makes it easier for our model to interpret the data. So let's continue here. So the next step that we need to run, I'm running the cell again on generating testing and training data set, is that we need to split the data set. And this is also super, super common when it comes to modeling, is that you don't want to use all of your data set to train the model, because then you have nothing to test it on. And you can't kind of show it all of your data to be able to test and validate it. So usually what you do is that you split the data either 80-20, so you do 80% training, or in this case 70% of the data used for training, and then we save 30% of it for the testing and validation. So a very common step that I'm sure you've encountered before in this context of machine learning. Now, finally, we reached the step where we're going to train the model. And I'm actually going to go ahead and run this cell while we're going to do this. So you see here that we're going to use an algorithm called logistic regression. And we're using the logistic regression to, and the formula that you see here pretty much tells us what it is that we're predicting. So we're going to predict the target column of this is tipped, because we want to know yes or no, will this customer give a tip? And these are the features that we are feeding the algorithm.